folks, thanks for watching the video. We at iCloudNow have developed a multi-cloud blockchain deployment framework that you can target any public or private cloud. We've been working on some of the well-known blockchain technologies such as Hyperledger Fabric, Ethereum, and R3 Corda, which is of interest for a lot of people, I think, in the industry. So what I'm going to do today is to show you a quick demonstration of how you can use this framework to deploy a sandbox environment for blockchain technologies on AWS and Azure cloud, right? So this is basically a blockchain technology which is targeted for multi-cloud deployment. And the focus areas would be today is on three popular blockchain technologies out in the market: Hyperledger Fabric deployment network, Ethereum network, and then adding nodes and distributed apps onto the Ethereum network, R3 Corda network, and Corda apps. But from a deployment perspective, we will be focusing on the demonstration more on taking the fabric and creating a quick sandbox or adding a remote peer in a true multi-cloud environment. Same thing for Ethereum network. Assuming there's a public network being already there, we will basically take the nodes and add to that. There could be an extension of creating a private Ethereum network. We could create as well through some settings, but for the demo purposes, we'll quickly add a node to a public network and see how that could be accomplished using our tool here. Third one is R3 Corda network. We will be creating a simple 3-node R3 Corda network with a sample application onto it, and how we can quickly deploy that using our network. So that's basically focus area for the demonstration. This is basically a diagrammatic view of what we're trying to do: Fabric, Ethereum, and Corda, which are enterprise-grade blockchain technologies out there today, and targeting them to various cloud environments, including Amazon Web Services, Azure, OpenStack, Bare Metal, or VMware. For the demo purposes, I'm using the first two cloud environments here, AWS and Microsoft Azure. Having said that, let's quickly switch to the demo. So this is the login screen for our framework. I could enter a user ID and the pass iCloudNow. All right, I am in the environment now. So this is the dashboard view of the framework. This view shows you how many projects deployed on which cloud. Each deployment is basically a project. You could also have projects stacked with the production staging, QA, dev, or any tag you desire. So it'll show you the tags here. This is the kind of a monitoring view of project status and a few other features. So with that said, we can quickly jump on, see what these two projects are here. So click on them, it'll show you these two projects which are deployed there. So this is a search capability. If I take out that, I pretty much have only two projects. On this environment, I could go deploy any kind of a project I need. So I could add a project. In the demo to get it quickly going on, I would add a remote peer to the existing Hyperledger Fabric network. So if you really look at my environment, I have a AWS console here, and I also have the Azure console here. There's nothing in the Azure console. Let's refresh the screen to make sure. So Azure is empty, but Amazon has a couple of virtual images out here. So this basically is 3-node cluster. What you see, it's a Hyperledger Fabric network with a Kubernetes cluster sitting on it. So these 3 nodes are, if you really look at the Kubernetes dashboard here, I have a bunch of components. These are all Fabric components. And I could hit on any service here, look at the logs and so forth. But for quickly to add a remote peer, I go back to my framework again. I can add a project which is now a Fabric peer. So I can say, hey, I want to add a Fabric peer to Azure. And I could say simply Azure peer, just to keep it simple. Azure peer Azure tier 1, right? Uh, I could add a project from a GitHub repository where I could have the entire infrastructure as a project, and code could be readily developed there, and then add a GitHub URL for that, or I could upload a project, or I can select from a template. So in our framework, each deployment project is nothing but an Ansible project. So you could go anything, write anything Ansible into it. What framework does out of the box is to do the provisioning for you, whatever the servers, whatever the orchestration you do for the nodes you want. You could simply, write it in a configuration file, and then there's an Ansible playbooks which would eventually go provision the servers for you, and then you could write multiple roles as an extension for your project. So for AWS and Azure, we have some predefined projects. For example, if you want to get a simple Kubernetes cluster as an example, we have a project. So you can define the number of nodes you want. It'll create the nodes and it'll create a cluster for you on a given cloud, right? Same thing, you want Docker binaries and Docker images to be downloaded from Docker Hub, and then you want the project. So we have a template which can get that for you. So in our context here, the projects of interest would be to deploy Hyperledger Fabric network, Ethereum node, and Coda project. So in this case, when I'm saying Fabric, I have a predefined project as a template. So I'm saying, hey, I want to deploy a Fabric peer and Azure cloud, right? And just give it a name as Azure Peer 1, then simply save it. So this would deploy a project into Azure environment. I can go back into Azure console, or I can look into the logs, see what's going on there. So this is the log. As you could see, the moment I kicked off, it's running a bunch of Ansible scripts to go create resources on Azure, right? So Azure Virtual Network creation and so forth is going on. So the idea is the end of this job when the project is deployed, this should create a node in the Azure environment, which we could go and look at in Azure here. This is my Azure environment. I would be able to see that this is adding a new peer. So it's adding all the resources required for creating that. So once the node is added, towards the end, this peer would enroll into an organization of a given network sitting on AWS here. So one of these organizations, so as you can see on Kubernetes cluster dashboard here. So what I'm doing is on CA1 STORGA, that's the one which was preset on that project in this case. If I look at the logs for this, end of the logs here, you would see that there is an enrollment request comes in. This is the earlier enrollment, but you will see a new enrollment request coming in, and you will see the logs reflecting that there is a new peer enrolled into this organization. So that's basically a peer connecting from Azure cloud into a Hyperledger Fabric network sitting in AWS, right? So you will see end of this execution when it is done, still creating a VM for us on Azure. Once it's done, it will go configure that, and then you'll see the logs reflecting that the peer is now ready to go. It's connected in the in the distributed environment with AWS and Azure sitting remotely. So your next step would be, once that job is done, all that you need to do is to join a channel and instantiate a chain code, and then keep writing your transactions, which are basically invoking chain code in the Fabric terminology, right? So that's an example of how a remote peers could be added to a given Hyperledger Fabric network, right? So this execution is still going on. Let's go back and see this is still working. So we got to wait 3 more minutes before that happens. So you can look at the Azure in the meanwhile to see what's going on here. All resources, so it's created a bunch of them. You got a virtual machine up now. Okay, so we got a virtual machine. So that's all going good. All right, we got the response back. So if you really look at the log, this is all the Ansible log output. So it's under the covers, it's an Ansible project which is executing, all the scripts getting executed to create the resources for us. Okay. All right, so I think we're ready to get some updates into this cluster here. This is 2241. So let's see when is the next update when it comes back. After this is done, we should be able to. Okay, it's 2341. Okay, so this is the actual step where it has all the provisioning has been done, and it has all the artifacts needed. It's now trying to get a Docker container. So the peer itself runs like a peer as a container. So it downloads the image and then creates the container. So we got the Fabric peer. This is successful here. Now if you go back to the log here, let me refresh this into the logs. There you go. See, there you go. 2342. There's the time where you see enrollment came in from this IP 172.168.1. That's the peer which is sitting literally on Azure cloud as a virtual machine sitting there. It has enrolled into a network, Fabric network, which is sitting on AWS cloud. So the peer is up and running. And the next step would be to join a channel and keep posting your chain code transactions from that. So that's at a high level how remote peers could be added to the Fabric network. You could also use our framework to create a new network altogether. What we did is a remote peer addition now, but I could go create a new network. It's as simple as saying add a project. Simply go add a project and then use a template Fabric network and then choose the choice of your cloud, give it a name. So this will create a simple Fabric network for you, which could be basically a multi-node cluster with a Kubernetes cluster sitting on it, and then Fabric components as parts sitting on top of the kube cluster. So this could be a true the Fabric sandbox environment for you, right? So that's at a high level how the Hyperledger Fabric network and the peers could be added in a true distributed manner. I will quickly now show an Ethereum node getting added. So this time I would use, I have a zip file now for Ethereum. So I could use an Ethereum node zip. I am trying to do AWS now instead of Azure and call it an Ethereum node, ETH node 1, for example. Save it. Now it's creating that particular project in AWS. Logs would reflect the same as the execution hits here. You will see log moving in. That new script project will kick off. There you go. So that is basically creating an Ethereum node 1 for you. Okay, authenticate to cloud, set up variables and so forth. So you will see, so the previous one was a peer on. So while this is happening, we can go back to Azure to see the peer. We didn't have a chance to look at it. So this is Microsoft Azure where we had a Fabric peer was added in the previous case. Now you are adding Ethereum node. This is the previous one, but I'm created one more instance now as it is executing. We should no, it's not started yet. Let's see. It's launching instance still. Once the launch is complete, we should be able to get a new instance getting started uh, on AWS. There you go. It's complete now. If you go back and look at here now, you should find that instance up and running, which is this one. No? Initializing this one, so Ethereum node. So this is the one which is getting started right now. So it's still initializing. We could grab a public IP in the meanwhile to log in and see what's going on in the node. Once it logs in, it'll try to log into that box just to show you what's happening in that node. So while here this is trying to SSH, it's not started anything yet, it's still trying to SSH. Once SSH has been done, it'll log in and then it'll try to bring in the Ethereum binaries into that box and then create a node. The interesting thing to watch here is the moment you connect a node in the Ethereum network, it will start syncing with all the transactions from the public network. Each node now, I guess, about 50 gigabytes of data. So it will try to bring in all 50 gigabytes of data into the node, so it'll sync in automatically into that. You would be able to see the transactions. I will just show you in a minute. If I have the IP address, I can SSH into that. Okay, make sure where I am. Ethereum. Okay, I am into the box now where this new instance is getting created. As you can see, it's still doing the job. Now start Ethereum mode. Starting the container now, so running the containers. Once the container is up, we'll be able to go back. This is done now. I can go back and see if the containers are up here. Sudo docker ps. There you go. I have 9 seconds back. I have Ethereum tools, Ethereum client. I have 2 containers up and running. I could look at the logs of container. So sudo docker logs for these Ethereum node. So this would show, if I say follow, this would show me continuous logs. Okay, so synchronization failed, block synchronization failed, IP endpoint open. Oh no, interesting. So it's not able to synchronize for some reason. There is an issue with synchronization. Cancel requested. Okay. Something happened with the synchronization. It couldn't do. I wonder what. Oh, there you go. Started on its own now. So it retried and now it's coming up on its own. So you see the transactions coming now. So this is what is all Ethereum transactions from public network. It's syncing your node. So this node is ready for mining and posting smart contracts into the public Ethereum network once it is done. So we don't want to wait for 50 gigabytes of download now. I'm killing this. All right, I'm not interested in keeping this node anymore, so I can exit this. But this basically demonstrates how you could simply add an Ethereum node. I'm just killing this node right now. I don't need it. Yes, terminate. Okay, so that's basically the example of how you could really add an Ethereum node. I could also create a real network based on this. I could have multiple nodes talking to each other, but there will be more like a private blockchain network sitting on Ethereum. So with a few configurations, I can make that happen. So you'll have a true Ethereum network environment that you can play with. All right, basically I define everything in the environment. This is my typical project structure as you could see, right? This is my Coda project with a bunch of variable files. The host file is just one node. I can have multiple nodes here, right? And you saw how what I did. This everything is a project here, as you can see. Coda is a project for me, and then I have a Kubernetes project that's a project from Ethereum is a project. So if you really look at Ethereum host file, as you can see, there's one node Ethereum node. I just created one node for that, right? So that's how it is. You basically tell everything through a configuration file here. Same thing we did Fabric Pure. Fabric Pure is a project. I have a host file. I'm telling this is the host file I need, right? And whatever the code I need to run, I would tell them through a playbook, a bunch of things which it does, right? So it's all driven regular and YAML code is executed through Ansible, right? All right, now that we have Hyperledger Fabric and the Ethereum node installed, let's try Coda. So I can go add Coda here by adding a project and give it a name, Coda1. Upload a project. It's in the form of a zip, Coda zip, and then put it on AWS. Save it. There it goes. Coda 1 is getting up and running now. So there will be scripts that will be running on AWS. So once it gets the tag, we could go look at the logs. There you go. Now the instance up. So we should be able to see that in AWS. It's launching. This is the one. I can copy the public IP to log into the box, just to see what containers it brings up once the job is done. Okay, let's SSH. I can SSH into this. Okay, I'm inside the box now. Once the job is done, we'll be able to see the application. So let's look for the logs, what's going on there. Okay, still trying to SSH and trying to get the binaries installed. So once the binaries are up, we'll be able to see what's going on in the virtual machine. We can log in and see what container it brings up. So basically what this app does is it creates a 3-node Coda network, assuming each node is like a bank. So in the sample application which Coda shipped, there's bank 1, bank A, bank B, and bank C. 3 banks are communicating. In addition, it would have a notary as another container and the network map. So you basically will see 5 containers coming up once the Coda installation is complete. We'll be able to log into the box and see those containers, and then there is a simple UI where you can look it up what's going on bank A, bank B, bank C. You can look at the UI hitting that container. So we'll wait for a minute for it to come back, and then we should be ready to go and check it out. So it's now trying to copy all the binaries. So the binaries have been deployed, and then it's trying to run the Docker Compose build, which is basically bringing the images for different containers and then up the containers. So Docker, so bought all the containers. Now we can go back and look what containers are up in that image. So sudo docker yes. There you go. We have, as I mentioned, we have 5 containers, 3 nodes for each of the banks, network map, and a notary. There's a simplified UI that we can hit for each of the apps. So I can grab the IP of this guy, which is this public IP, and then I can use the port number 1004 to see what it is it's going to show. So I have the IP copied here, and I could go simply say, hey, show me what. There you go. So I got this is basically what simple Coda app sitting on that bank A. So it shows you, what it has, JSON structure of the data there. This is empty peers. It has peers, Bank B is one peer, and this is the network map. Bank A and Bank C. So three peers sitting on with the network map on it. So it's showing all the peers which are part of the network. This one it's not working. Yeah, so that's basically is for node 1, and I can go back to bank B, which is a different IP. So I got the same information there too. So it's a different. So this is bank B basically. So I'm looking at bank B, and I could look at the peers, same peers part of the bank B. Same thing, I can look it up in 10044 will be bank. That's going to be bank C. So me, that guy, he's going to be bank C, right? And then he has all the peers who are participating in that are, same thing, bank B, bank C, and bank A. So basically, that's at a high level demonstrates the CODA network installed and a sample app sitting on top of that, right? So that's pretty much, folks. At a high level, we have seen 3 different blockchain technologies installed and up and running in the sandbox environment in less than 20 minutes, I guess, about 20-25 minutes. And for the Fabric, we got the network all installed. That takes a little about 10-15 minutes. So I didn't install it from the scratch, but I just added the peer, Azure peer on the Azure cloud. Ethereum also added a node, assuming existing network is there, but you could also build your own network with multiple nodes. So Ethereum works slightly different there. And the CODA was the simple 3-node container, like 3 banks simulated in a single environment there, but we could as well keep adding nodes across with the configuration so it becomes a true blockchain network per se. That's pretty much, folks. Thanks for watching the video, and if you have any questions, you could respond back to us below this video. You will have my contact details. You could reach out to me if you have any questions. Thank you very much.